Okay, for today, we'll mention some additional notes for the Taylor-Maclaurin series. Okay, so um, my suggestion for uh, the Taylor and Maclaurin, there are at least 1, 2, 3, 4, 5, at least six. We call it the maybe a functions that frequently appear or a functions that can be expanded. Okay. So when you are observe 1 over 1 minus x or e to the x and sine, cosine, tangent inverse, ln 1 plus x, all these functions you can expand and you can make a series. So you can make the 1 plus x squared, blah, 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 the power series. All of this, you can make the power series, okay? And I hope for the last two, you can make it by yourself, the tangent inverse and ln. The key is the tangent inverse, you can relate to the integration, uh, which is 1 over 1 plus x squared. And you can relate that to the first one. It's similar, right? 1 over 1 minus x. Okay, so it's similar. So you can what you can do is you can replace this x squared with, so it will be replacing this x. Okay, so that's what you can do, and then use the integration or differentiations. Same with the 1 plus x here, ln. Okay, you can have the ln, and you can have the if you differentiate this, you will have this, right? And this also relate to this, right? Okay, and you can have this relation. So replace x with the minus x. And then if you integrate this, it will become this, right? So the same with if you have the series, you can integrate, and that will be the series for ln 1 plus x. The same with this tangent inverse. Okay. So whenever you find this, if you integrate, you will get back to tangent inverse. So differentiate, integrate, that's what you can do. So if you find in your textbook exercise some functions that are composed of these 6 functions, you can relate to how to actually the first one is this 1 over 1 minus x. This is the important one, the most basic one. So usually you can relate to this, and then maybe the sine and cosine. And most of the questions are actually combinations. It's a combination of multifunctions. Okay. There is one function that I didn't mention here. It's binomial, a binomial theorem, but I will skip that. So whenever you find the square root 1 plus x, this should be you can expand this actually, but I will skip this for now. It's using binomial, so I will skip all the binomial for now. So you can just focus on the 1 over 1 minus x, e to the x, sine x, cosine x, tangent inverse, and ln, because I think this is all most frequently functions that are used in engineering and its application. Okay, so uh, to begin with, what we can manipulate. For example, if you have, let me write here, uh, evaluate, you have the limit. Now it seems it's a questions with limit, but because you are now have learned the Taylor and Maclaurin, you can exchange the e to the x to the expansion, to its expansion, to the series. And with that expansion, you can solve this limit. Okay, so that is one applications for the Taylor and Maclaurin. You can exchange the functions, and you can solve and find alternative solutions. If you maybe forget the e to the x, let me write here. That is our e to the x. And to solve the equations, at least you need to expand this, the sum, into a few terms. Okay, at least few first terms. Uh, Maybe until just 3, maybe that's enough, because if you are writing all, you will waste your time. So just make it like that. And then if you are seeing here, this is 1 plus x, and this is -1, -x. So from here, we can cancel this with this 1 and x, right? So let me write in the complete solutions. So let me write using a bracket so you can see this is for e to the x. Now you have 1 cancel and then x cancel. Okay. Now all this with the x squared divided by 2 factorial and so on and so forth, it's divided by the x squared. Oh, I forgot to write x squared. So then you can minus to the power x squared divided by x squared, right? So you will have limit Okay, and now we can clearly see if x approaching 0, so all x will be 0, and the answer will be 1/2. Okay. So similarly, if you see in any exercise in your textbook with the limit, and you see the basis functions that I mentioned, the 1/1 minus x, e to the x, sine x, cosine x, tangent inverse x, and ln, 1 plus x, you can exchange that with the series. Okay. And how to write them to 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 um, to make your answers not really that long, you can write maybe 3 or 4 terms, like maybe 1 plus x, and then until the cube, and then just dot dot dot. And but careful, sometimes maybe you need to add a few more. It depends on the how complex the question is. Okay. Okay. So that's the first thing. So you can evaluate the limit, and you can exchange with the series. Okay. So please remember this 4. Okay. Okay. Any questions? Any question for now? Any questions? So the key is exchange the functions that you are familiar with, the 6 functions with the series, with its series. Okay. So expand the series. Okay. Now another thing aside from the limit, we have the let's say if we have the functions e to the x and sine x. Maybe the question is about the how about its Maclaurin series? What it looks like? Maybe that's the question. Now, if this happened, then we see the functions first. We see the e to the x. We already know what's the power the expansion of its series. Sine also we know. What we can do is now we can multiply. So it's you need a lot of some calculations there, but it's I think it's not too complicated. It's just maybe a little bit long, a little bit long. For example, if e to the x is like what we discussed before, let me write here. Okay. Oh, by the way, if you see the pattern, okay, if you see the pattern on how the series looks like, e to the x and then sine x, especially sine, cosine. Sine and cosine, you will see it's an odd number, right? 1, 3, 5. The cosine is the even number, 2, 4, and so on. The tangent inverse and ln also similar, but without the factorial. If you try to make your own series, and it will have um, the odd and even number, similar, but without factorial for tangent inverse and ln. Now, to solve the questions, what's the Maclaurin series for this problem? We can multiply the e to the x and sine x, which means we need to have some calculation here. So let me write here. Let me just write until here so that you can see clearly. Or you can maybe, if you're confused the long numbers, maybe we can write as and maybe we can calculate the factorial. And the sign will be minus x cubed. So you can just multiply like in the elementary school. So x and 1 by 1. But to help you for writing, You can just a few terms, okay, just a few terms, and see what the result. Okay, you can check when you, if you want, like maybe adding a few more terms. But because I think the sign having only odd number, you can skip the part here, right? So it will be a lot shorter. So if you multiply x with 1, it will become x, and then plus x squared plus x cubed over 2 plus x4 over 6 plus, that's the one. Okay. Oh, wait. This is 3 factorial, so 6. Okay. Yeah. And the other one, we can calculate this, right? So let's and it will always having 6 at the bottom, and maybe plus minus and you will arrive at the result. So this is just adding both of these equations. We have x plus x squared minus, and uh, you can stop here actually. Just stop here. That is okay. That's the case for multiplications. Okay, for so you need to multiply. Which one? Oh, here, oh yeah, right. And then the other one, let's say we have functions tangent x. So this part, the part before, you can multiply, and you can multiply the series. So the functions, you expand the functions and multiply inside all the plus. You can try maybe 3 or 4 terms, like a few first terms, and do not try like really a lot. Do not try that. Maybe just 3 or 4 terms. That's will be okay. And then the other one, the other functions is tangent. And now, instead of multiply, now you have a tangent, which are sine and cosine, right? And we know sine and cosine, they both have the expansions, right? And instead of we multiply, we are now divide. Sine divided by cosine. So all the terms divide the terms for the cosine. So let me maybe write for you what is sine and cosine. Sine is x and having the odd number. And then cosine, it starts with 1, right? Different from sine. So it's the complementary or for sine. So it will be having an even number now. Now, what you can do now, we need to divide this with this. The x blah, 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 and divide by 1. So at least uh, you know that this is polynomial, right? Polynomial. And in polynomial, you know how to work out the long division, the long division. So we can do the long division here. And we need to calculate the factorial. Okay. So let me write in another color. So x minus x cubed divided by 6 plus divide by 1 minus half plus 4, 3 to 24. Okay. And wait. At least 3 terms for you to, and we divide this, find the results here, okay? And we will have the remainder at the bottom. Okay, now we start with x. So multiply to the left, we get x minus x cubed and plus and we need to minus this. Five, yeah, five, 5, 6, 5, yeah, and and do one more x cubed. So this will be x cubed divided by 3 and minus x5 divided by 6, and this will be minus. So this cancel, right? So 4 over 30, 2, 15, right? 2 over 15. I still have another terms after this, but we can just stop until here, and we can write the answer or the results for tangent x is x plus and then plus dot dot dot. Okay, so anytime you find any composed functions that you can think, like you can multiply or you can divide from the 6 functions, okay, from the 6 functions. Let me write here so you remember which the functions is. That's this 6 function. Okay? So you can combine those functions into multiplications or division, or for maybe you want to multiply sine or cosine with x squared, x, or any other functions that may be easy to be replicated inside. That also can be done. But the idea is this 6, okay, usually, okay, for the Maclaurin series. Let me give you a few example, maybe. Um, okay, any questions from here? Okay, maybe we can go to some maybe 1-2 exercise, and then I will move to the other chapters. Okay, maybe we can start with yeah, the question is already prepared. So if you check the limit, it's 0/0, right? Yeah, but maybe I need to make the questions use series to evaluate the limit, to restrict the answers to the series. So you can try use this series to evaluate limit 1 minus cosine x over 1 plus x minus e to the x. And this is number 1. Number 2, find the function. So number one, 1 minus cos x divided by 1 plus x minus e to the x. Number two, this is the power series with alternate sign, minus 1 with power of n, and then x with the odd value to n plus 1, and divide by 2 to n plus 1, the odd value, and multiply with the 2n plus 1 factorial. And the key for the chapter 11 mostly is to try and error. Okay, so from the beginning, like the sequence, series, and then some method to find the convergence, and then radius of convergence, and so on and so forth. You need to try and error, try the method. Okay, especially the Maclaurin series, you need to try and error. Especially, you need to be able to determine this six. Okay? And how to determine this? Okay, if you are determining the Maclaurin series, you need to find maybe a few terms derivative for each function, and then apply 0, expand the series, and that is your power series. And you need to make the formula from that expansion. Okay, number one is 1 minus cos x over 1 plus x minus e to the x. Number two, you have sum, and then minus 1 with power of n, x with power 2n plus 1, divide by 2 with the power of 2n plus 1, multiply with 2n plus 1 factorial. Maybe giving you some couple minutes to try. So some variation for the textbook problem. Aside from finding the Maclaurin and so on, you need to evaluate the limit using series, and then find the uh, find the function from the series. Okay. And then if it is having more than one function, for example, you need to multiply or you need to divide, you need to do that and find the expansions. And don't forget that because the limit is having x approaching 0. So at the, maybe you simplify, find some solutions. You need to just apply x equals 0 and put into the equation of limit, and you will have the answers, I think. Okay. Yeah, this you can just write all the expansion. Yeah, the series. You forget. Okay. Maybe as a shortcut. Okay. I'm giving you the 6 functions that I mentioned. Let me just write the shortcut here, so you can you can write your notes, okay, based on this shortcut. So first is 1 over 1 minus x. This will be, and then e to the x, and then the tangent inverse. Okay, and this is the 6 functions, and I will upload the notes. So if you are maybe missing something from the previous slides, I will give you the all the notes. Okay, all the notes, so you can focus on the six series here. Okay. Now, for number 1, the functions is we can input the cos and e to the x, right? So we can replace place to the original limit, and using e also replacing the e at the original limit. Okay, so, so number 1, so 1 minus the cos x is the value here. So 1 minus, okay, and then 1 plus x. Oh, um, e to the x is this, so minus 1 plus x Okay, now we can cancel some value here. We can cancel this, we can cancel this and this. Okay. And we can divide this divide with this. Oh, it's minus, all minus, right? All minus. And actually, if you are using the long divisions, you will get the answer eventually. But if you see here, you will get the most obvious one is from this x squared. You will get at least it will be half and negative half. So probably it will be around -1. And you can check with the long divisions to check. And after you check, you can divide this and you will have an expansion. The expansion will have at the front is 1/2 and then all with x. And x is 0. So all will be 0 except the half, right? Except the -1. Yeah. So this is the answer will be -1. So you can try the so you will have -1 at the front here, right? And you will have some plus, and then you will have plus blah 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 blah, and all this will having x, which means it will getting 0, right? So the answer will be -1. Okay. Um, do you get it? Why it's -1? Okay. So you can define first, and then later you will see it will having x here, right? And because limit x is 0, then all x will be 0 except the front, the constant, right? So that's why it's -1. Okay. Like maybe in the exam, you can like make a short story and make this. That's okay. That's okay. Because it's quite logic, right? From here, right? and then it's limit x is 0, and that's the answer, -1. Okay, another type of questions, the number 2, you will probably will be asked to find what kind of functions is this. Okay, so we have like this the odd functions, x to n plus 1, and then you have the 2n plus 1 factorial also. Before we are going to maybe try error, uh, you can check here. Remember this form? Check from here, from the first one, 1 over 1 minus x, okay, e to the x, and check with the which one we have the 2n plus 1. I think we are getting close here, right? It's having 2n plus 1, having 2n plus 1 factorial also. So the top and the bottom is similar, okay? So let's see again our functions here, okay? The difference is just these two, but it's just a constant 2, right? So if you want, we can rearrange the form because it's having the same power with this. We can arrange this as x over 2, right? Okay. So let me arrange this. So number 2, let me arrange all the sum. Let me check the questions. So the x over 2, 2n plus 1. Wait. Too big. And divide by 2n plus 1 factorial. Now it's becoming the same form or similar form with sine x. Now remember, this is sine x, so with x, it's x, right? Now we have it's x over 2. Maybe it's too small. So x over 2. So it's sine x over 2. Okay, that's one way to look at. So the functions will be is sine over 2, x over 2. Okay, and same way with the other question you find in the textbook. You can check the original, the basis one, but my suggestions, okay, for you, um, you need to try at least find the this uh, these relations, okay, all of this from the first one, and then the e, sine, cosine, tangent inverse, and ln. Try by your own, okay. Find um, the conclusion. Find this, okay? Find this formula, but with your own words, okay. You need to at least try. My suggestion. So you will be familiarized with this, and this. The how the um, how the sum looks like. Okay? Because if you just remembering the sum without without trying how to find it by yourself, it will be a little bit difficult if you are trying to understand the whole concept behind it. So my suggestion is try find by your own how to find this. Okay, just like what we did in the previous lectures. Okay, so especially for the tangent inverse and ln, you can try the integrations, differentiations. Okay, you need to relate this tangent inverse to 1 over 1 plus x squared, ln with 1 over 1 plus x, right? Okay. Okay, that's the additional notes for Maclaurin series. Okay. And by the way, I think at the beginning of our course, I think I asked whether you want to have a break 5 minutes every bell, right? Or you want to finish early. Like for example, the class is finished at 3:10, right? The bell break time is 5 minutes, 5 minutes. So I'm minus 10 minutes. So you can get out 3. We agree that, right? So if you are disagree, please don't make some complaint about the short time we are having in the class, okay? Because we had agreement, right? Okay, clear? If you want to have like maybe some other suggestions to have the break time, that's also fine with me. Okay, okay, okay. Back to the Maclaurin. Um, Actually, in the textbook, we still have one section 11.11, 11.11. But because that is more likely to be applied in a more how to say that, for application in computations and iterations. So I think I will skip that for now because it might be too many chapters for you. So I will skip the last section 11.11. Okay, I will skip that and I will move to the new chapter, okay, the vectors. So my plan actually for this week, we move to vectors, maybe some introductions and maybe some refreshment because I think you already know about the factors. Okay, so up until here, I will upload the notes into the Moodle so you can review the notes. Okay, the chapter 11. Okay, so again, the midterm is chapter 10 and 11, 2 chapters. Okay, only. But we are now moving to chapter 12. Okay, for a short up until before the midterm. Okay. So that's the all the Maclaurin. So we will move to the chapter 12. It's called the vectors and geometry of space. A bit review and how to see the vectors through this the geometry. So it's geometry. Okay. Okay. Now to begin with, let me just remind you with the 3 dimensions coordinate. Okay, this is x, y, and z. Okay, the default why this happened is you can remembering through your right hand, right? This is being the x, your palm is the y, and your thumb is the z. Okay, just a few a reminder. That's the coordinate system in three dimensions. And then how do we apply the coordinate? Usually we call this this point the O or the 0 or yeah, we call it the origin. Okay, whenever you design, maybe some of you are using some software like SketchUp or any AutoCAD or any 3 dimensions software, and you can rotate this and you can see from any angle, right? And I think that's good uh, for this chapter, okay? Because in the next in the last section of chapter 12, we will learn some complicated graphs. Okay. Okay. Now if we are start from this point origin, let me maybe make some travel. Okay, let's travel to this axis, maybe a unit. Maybe not travel, just making some coordinate. Okay, so let's say this is a, and then going here it's b unit, and then going here it's c. So if if I define this point P, this will be A, B, C. Okay, this is X, this is Y, this is Z. Okay, so that's how we find or how we define the coordinates in 3 dimensions. Okay, okay, and another thing in uh, in 2 dimension we are having X, Y, right? And we are having the outcome of this is a curve, right? By taking point by point, and then we can make a curve. Okay, we call this is in the 2 dimensions like that. Okay, in 3 dimension, we are having X, Y, and Z. And what is the outcome of these 3 coordinates? It's not just a curve. It's not just a curve. It will be a space, or we can call it a surface, or even a solids, because we can make 3D models, right? We call this in the R and then cube. So for example, let's start with equations. Okay, so example, let's start with equation just z equal 3 or y equal 2. So to begin with, let's just draw the coordinate at the axis. We have 3 axes. Okay, to begin, we can take z 1, 2, 3. This is our z here. Okay. Now, if we are only having one information about z, z is equal 3. What kind of shape it does in a 3 dimension or 3D Cartesian? Okay. Like yeah, yeah. So if you see the z here, of course the x and y is not, it's not there, not in our information, right? So z is like, let me draw for you. I hope you can see clearly what kind of shape is this. Okay, so this means, okay, this rectangle means at the level of 3, you are kind of seeing a plate, like you slice. So if you imagine this like in a solid, you are slicing at the level of 3, but the x and y is actually infinite amount, okay? Because we are not having any information on y and x. Okay? So it's actually a surface that slice 3, slice 3. Okay, like a plate, like a plate. Okay, And if you are having y equal to, let's say 1, 1, 2. Now this become but I think my drawing is bad. It looks like it's slicing here. Yeah, just up, how to say that, the error from human eyes. So it should be slicing too. I hope you get it. Okay, I hope you get it. So it should be slicing this. Yeah, yeah. Oh yeah. Maybe we can. Oh, or maybe just adding this. Is it helping? I think no. Okay. Maybe if we are having this 4, maybe we can change this to 4. Yeah, maybe 4. Oh yeah, yeah, yeah. That's also okay. But I think you get it, right? You get it? I think you get it. Okay. Or you can try the software and then just put in z equals something. In 3D, it will having um, infinite amount in x and y for z, and infinite amount for z and x for this y. Okay. 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 That's the first example. The second example, if you have x squared plus y squared equal 1 and z equal 3. Okay, let's draw the 3 dimensions, the axis. This is the x and y. Uh, y. Now, you have the circle and you have z equal 3. Okay. From before, we know the z equal 3. Okay. It's cutting this level, right? So maybe I'm writing the 1, 2, 3, maybe this around here. But now we have x and y for the informations, right? So it's the same or similar approach. We slice the tree here, we slice z, but we have restriction. We limit the x and y with a circle. So it will be like this. Yeah. Okay, I hope you get it. Imagine this is a circle if you see from the top or from the bottom. Okay. So if you have like software to check the graph, it's better because you can rotate and take a look around, and that's really a good approach. And learning how to see the 3 dimensions is actually helping you, especially if you want to maybe making a design like 3 dimensions model. It can help you to see how it translates, okay, how the like from the formula to the graphs, how it translates well. Okay, that's the example. And then the questions: uh, what if you are having only x squared plus y squared equal 1? Okay, without any z, but in 3 dimension axis. So the first thing you know that this will be a circle, right? In XY, if you see from the top, from bottom, this will be a circle here. So this and this. And maybe I will make a circle like this. So because without any information of z, so which means the z is actually going up and going down infinite amount. Okay, so it will be like a cylinder. Okay, so it become a cylinder. And then if you limit or you have restrictions for the circle, for example, if you have let's say the x squared plus y squared is less equal 1, and you are having not 1, maybe 2 to 4, which means the cylinder will be limited from z equal 2 until z equal 4. Let's say this is the 2 and this is 4. So this is our cylinder. Yeah. So cylinder is um, we will heard and be informed about cylinder up until later chapters. In the multiple integral, we will meet with the cylinders again. Okay. Okay, that's the space, and the other part in this intro, what I want to show you is the distance. Okay, the distance between points, distance in 3 dimension. So whenever you have maybe point um, this is P1, okay, and then this is P2. Okay, and you want to know the distance between. Then you can apply the distance formula, which is derived from the Pythagorean. Okay, so this is the formula, and plus I don't think I need to prove for you, right? I think it's already mentioned many times before. And from this formula, we can apply for sphere. Imagine this is a sphere with radius r. Let's say this is xyz, and the center of the sphere is HKL. So let me write C is HKL. So the radius or the distance of PC, okay, this will be x minus h squared plus okay, that's the radius. And if we square this, this become equations of sphere. At the center, HKL. So at origin, you have this formula. This is sphere at origin. Now to try out how we are visualizing the sphere, let me write the equations. Uh, what region in third dimension is represented? So you have this inequality, 1 less equal x squared plus y squared plus z squared less equal 4. So if you have this, can you imagine what the three dimensions shape look like? The first thing you know, this x squared, y squared, z squared is the sphere. Okay, so it's a sphere. Okay. And the question is just asking what region in the three dimension is represented. Okay. Like what? And this the empty space inside, right? Yes. Yeah. Okay. So to look at the inequality, we can look this as if you square this, we have this relation in which this is our radius, right? The radius. And if we are dealing with the, the picture, let's say this is 1, 1, 1, and this is 2. So it will be so in the middle side like that. Or if you see from outside, just you're just seeing a ball. Okay, but actually this ball is having another ball inside. This is 2 and this is 1. Okay, this is just a review and refresh how to look at the 3 dimensions. Okay, so if you are having inequality in sphere, if you draw like from the all the sphere, then you will not notice what's the difference because you are seeing just like a ball, right? But it's actually having a empty space inside here. This is the half ball, okay, the half ball. If you cut the ball into half, okay, and if you look at the whole sphere here, you will see an empty space inside. Okay, that's the way you are imagine the sphere. Okay, that's the introductions for the vectors, especially the space. Okay, the geometry in three dimension coordinate. Okay, now I will move on to the next one, which is the definition of vectors, and I think um, you already have you already learned before, and maybe this is just review for you. So I will maybe just point out what's the key point for all of this. Okay. So vectors usually it's represented by arrow because it's having directions. Okay. The important point in vector is having directions. Okay. So having a direction. So not only a value, but also directions. And how we write the vectors, we can write that with just like this, or we can write with the arrow like that. That's also fine. Which one you are preferred, it doesn't matter. You can choose. And a vector, it's having always having an initial point and a terminal point. And then if we are combining two vectors, for example, we are combining this and this. Let's say this is the arrow here. Let's say this is the U and this is V. We can make a conclusion of this displacement. So we call this the addition U plus V, and that's the directions. Or maybe if you want to have a point, so from A, B, and C, you can also rename A, B, C in terms of vectors. It becomes AB plus BC, right? And it's become AC. And this is usually we call this is the triangle law for vectors, but the name is not really important. As long as you know the applications, that's okay. And also the other one you might remember, you have this. So if this is u, you can have the parallel factors. And this is what we call the parallelogram. So it's called the parallelogram. So it will be, if you see from here, it's u plus v. From here, it's v plus u, which is the same result. Okay, maybe we can move. Okay. The next thing in vectors is this scalar multiplication. So if C is scalar, which means only the value, not without directions, and V is a vector, then CV, this scalar multiple, is the vector. I will write the complete sentence, but whose length is C times C times V. And direction, the same as V if the C is positive. And opposite direction if C is negative. If C is 0, then V is 0. If C is 0 or V 0, then CV is 0. Okay, that's better. But perhaps a better approach is just showing you the picture. So if this is U, if we are multiplying with half, then it will be half U. If we are multiplying with the negative 1, it will be negative U. And maybe multiply with the twice amount, it will be negative 2U. Okay. That's what the definitions means. So from this positive, negative, if we have, let's say, this is V, and this is, let's say, U. So if you want to write V and then plus U, you can have this relation. And if you want u minus v, we can have, let's say this is u, this is u, and then the opposite side of v is here, and this will be the results. So this will be u minus v. This is. Okay, another point that maybe you will see a lot is components of vector. In 2-dimension, usually if A is vector, so if A is vector. So let's say A, the component in 2-dimension is having two components, component X and component Y, right? In 3D, we have three components. And usually it depends on the initial point. The default initial point is at origin, or 0, 0, or 0, 0, 0 in 2-dimension and 3-dimension. So if given points A, x1, y1, and z1, and B, x2, y2, and z2, the factor AB will be x2 minus x1, y2 minus y1, and z2 minus z1. This is if you have different initial point, like this initial point is start from A. So from A going to B, so the vectors will be the difference from B to A. And then lastly for today, the length or magnitude. For 2-dimension, the length is squared of A1 squared plus A2 squared. In 3D, same. 3D the same, but with the three components. So this factor is A1, A2. The factor is A1, A2, A3. Okay. So I will stop until here. The rest is still some review and property of factors. And after that, we will move to the dot product, the cross product, equation of line and plane, and lastly, for chapter 12 is the surface, the quadric surface and cylinder. Okay. So we still have another day this week completing the factors, maybe dot product and cross product. And next week, maybe completing some sections in factors. And after that, maybe some review for your midterm. Okay. Okay, any questions? Any questions? Okay. I will upload the notes, okay, chapter 11 notes to the Moodle. Maybe also the answer for quiz before I will upload also. And yeah, I think I already give the exercise, the PDF file, right? So you can check that out and see some exercise. Okay, try some exercise because the key for chapter 11 is try and error. Okay, so I think that's it for today. So yeah, I will close this.